Hello, science fan. We are going over our quiz review with reaction types and balancing and all of that good chemistry goodness. All right, let's look at number one. Why do you need to check the activity series chart first before you can complete a single replacement reaction? So the question is, when you look at that activity series, remember the elements on top are more reactive than the elements on the bottom. So when you have a single replacement reaction, remember that that lone element by itself, this one, letter A, has to be stronger than B in order for the reaction to occur. If it doesn't, then there is no reaction because A would try to kick out B, but B is stronger. So make sure that you write that down properly in your own words, why it is important to check that activity series first. If we look at question number two, what type of reaction is this? Well, I think we just went over it in question number one. You have one compound and a lone element trying to swap out one of those ions in that ionic compound. Remember, we call that type of reaction a single replacement reaction. For number three, what type of reaction is two compounds and it looks like their cations swapped? Remember that that is a double replacement reaction. Just a reminder, we have to have one of the products become a solid in order to have that reaction occur. Looking at question number four, if we have one solo compound by itself and it breaks into pieces, we know that that type of reaction is called a decomposition reaction. For number five, what type of reaction has the mathematical format A plus B? So we have two separate items, but as a product, it forms one compound. Remember that that is a synthesis reaction. For number six, what type of reaction is this chemical format? Well, you have a hydrocarbon, carbons and hydrogen, plus oxygen, and it always gives you water and carbon dioxide. We know that that is a combustion reaction. So a big question, people get confused with the numbers here, but for number seven, what are subscripts? Remember, subscripts are the numbers that are small and in a compound. So for example, something like magnesium chloride, the little 2 is called a subscript. So then the next question naturally is for number 8, then what's a coefficient? Well, a coefficient is the big number used in balancing a chemical equation. So for example, if we had something like methane is going to combust here, give you CO2 and H2O. All right, we would need, in order to get the 4 hydrogens, we would need to balance this out with the 2 in front. So for coefficients, that big number used for balancing, that is what a coefficient is, okay? All right, well, let's look at number 9 then. First thing is they want us to tell what type of reaction is this, and then also balance it out. Well, first of all, we have 2 individual separate objects coming together as one compound. I think we can call that a synthesis reaction. And if I wanted to balance this bad boy out, let's see here. I've got 3 oxygen and 2 oxygen. So I'm going to need to make those both 6 through multiplication. But now that I did that, I also made 4 iron, 2 times 2. So I'm going to have to put a 4 there. So 4, 3, 2 balances that one out. If we take a look at number 10, you have 1 compound splitting into pieces. We know that that is called decomposition. And if we want to balance that out, there's 1 oxygen over here, 2 oxygens over here. So I think I'm going to have to put a 2 there. That is now going to make 2 hydrogens though. So I'm sorry, 2 times 2 hydrogens, which is 4. So I'm going to need a 2 times 2 to balance that out. So that becomes a 2, 2, 1 for balancing. If we look at our next one, we have an individual element trying to jump into a compound. So if we notice calcium's now all alone on the product side, that's going to be called a single replacement reaction. I'll just do single R for short, since we're just doing a help video here, but make sure you spell it out all the way, get used to it. Let me take a look at how we can balance that. There's 2 chlorines here, 1 here. So I'm going to put a 2 right there. That's going to give me 2 lithium. And I think that balances out. 2, 1, 1, 2. If we take a look at number 12, there are two compounds, and there's still two compounds on the other side, but it looks like the cation switched, so we know that is a double replacement. I could put DR or double replacement, but that is what is happening. So let's try to balance this out. First of all, I've got two chlorines and one here, so I'm going to put a 2 in front of there. That's going to give me 2 silvers. I only have 1 silver here, so I'm going to put a 2 there. That's going to give me 2 nitrates, but I already have 2 nitrates there, and I have 1 calcium, 1 calcium. So 2, 1, 2, 1 balances out this double replacement reaction. Looking at our final one, number 13, it's a hydrocarbon with oxygen giving us water and carbon dioxide. That's always a combustion reaction, right? So I'll put combust for short, and let's balance this out. These ones are always fun to balance. Remember, I always suggest you balance carbon first, hydrogen next, and then oxygen last. So 9 carbon, let's put a 9 there. 20 hydrogen, 10 times 2 is 20 hydrogen. Now the part that we want to see, if I have 9 times 1 oxygen, I have 10 oxygen. 9 times 2 oxygen, I have 18. 10 plus 18 is 28 oxygen. So I'm going to need 14 times 2 to give me 28. And that leaves me with 1, 14, 10, and 9 to be completely balanced. All right, page 1 complete. Page 2 of the quiz review coming at you. These look like single replacement reactions. So the question is zinc going to come in and kick out lead? Well, zinc is right here, and lead is below it. So zinc is stronger. So what does that mean? That means lead is definitely going to get kicked out by itself, and that means zinc is going to form with acetate. Now that we have our products predicted, we can figure out how to write this in a chemical equation. So zinc by itself is just Zn, but lead-2 is Pb2+, and acetate, if we look on our ion sheet, is C2H3O2, and remember that has a -1 charge. I found that on my ion sheet. You're not expected to memorize that, so just make sure you look it up. Next is lead by itself, that's Pb. And then zinc, acetate, zinc's gonna have a +2 charge. Acetate is that long one, C2H3O2, and overall that has a -1 charge. Now that is not my answer, that's just my notes. I need to put these together so that I can write a nice balanced formula. So zinc is here. Now I've got lead is 2+, acetate is -1. So I'm going to need 2 of those acetates. So it's C2H3O2 with 2 of them to balance out with the +2 lead. Now lead is by itself on the product side, and zinc is the same thing. Since zinc is 2+ and acetate's -1, I'm going to need 2 of those acetates. Sorry, I'm overlapping a little bit to balance out. Now that I've done that, all that's left is balancing this, but it actually all balances out. 1 zinc, 1 zinc, 1 lead, 1 lead, 2 acetates, 2 acetates. 1, 1, 1, 1. And you're all balanced up. All right, nice. Well, let's go to the next single replacement reaction. I've got aluminum coming in hot going against magnesium. I guess we better check if aluminum is stronger than magnesium. So here's aluminum, and just above it is magnesium. So magnesium is higher on the chart, so magnesium is stronger. So when aluminum comes in and says, get out of here, chloride's mine, magnesium says, no way, I'm stronger than you and more reactive, I'm staying. So therefore, aluminum cannot kick out magnesium, so we can say that this single replacement is no reaction. This is exactly what the question was asking from number 1 in this quiz review about why do we have to check this activity series before we do a single replacement reaction. That's to make sure there actually is a reaction. Well, let's finish up number 16, 17, and 18. These are combustion reactions, so we know that the 2 compounds that are always going to form as products is carbon dioxide and water. Because whenever you have a hydrocarbon reacting with oxygen, you always form the same 2 products. So the only difference is going to be that when we balance, the balancing will look a little bit different. Remember, for combustion reactions, I always balance carbon first, then hydrogen, then oxygen last, because oxygen is in 2 places on the product side. So let's start with carbon. 2 carbon, I'm going to put a 2 there. 4 hydrogen, I'm going to put a 2 there for 2 times 2. Now let's count up how many oxygen we have. 2 times 2 oxygen gives me 4. 2 times 1 oxygen gives me 2. 4 plus 2 gives me 6 oxygen on the product side. So I'm going to need a 3 here, and I balance that out. 1, 3, 2, 2. Perfect. Next up, 3 carbon. Let's put a 3 there to get 3 carbon. 6 hydrogen, so 3 times 2 is going to give me 6 hydrogen. Let's look at those oxygens though. 3 times 2 gives me 6 oxygen. 3 times 1 gives me 3 oxygen. 6 plus 3 gives me 9 total oxygens. So that means I'm going to have to do 4.5 times 2 to give me 9 oxygens. If you recall, though, I can't just leave that 4.5. It's not possible to have a half of a molecule in a balanced equation. So I'm going to double everything. 1 becomes 2, 4.5 doubled becomes 9, 3 becomes 6, and 3 becomes 6. Now everything is still balanced, but 4.5 is now a whole number. So 2, 9, 6, 6 balances this out. Balancing number 18, 4 carbon, I'm going to put a 4 in front. 10 hydrogen, 5 times 2 gives me 10. Let me look at those oxygens. 4 times 2 is 8. 5 times 1 is 5. 8 plus 5 gives me 13. I have 13 oxygens. 6.5 times 2 oxygen will give me 13. So now I'm balanced, but I can't keep it at 6.5 because we need a whole number for all of our coefficients. So I'm going to double them all. 1 becomes 2. 6.5 doubled becomes 13. 4 doubled becomes 8. 5 doubled becomes 10. Now we have it balanced and all coefficients are whole numbers. So we are all set. That concludes page 2 of the quiz review. Let's go to page 3. We are now looking at double replacement reactions because we have 2 compounds coming together and potentially swapping. So when we do that, we're going to swap the words. So first is going to be silver chloride. And then the next compound is going to be potassium nitrate. Now remember, for double replacement reactions, we have to make sure that one of these is a solid. If not, then we're going to say that there was no reaction. And by the way, could you have written potassium nitrate first and silver chloride second? Absolutely. It doesn't matter what order you write them in as long as you have silver with chloride and potassium with nitrate. Let's take a look at our solubility chart to make sure that one of them forms a solid. Let's do silver chloride first. So here's silver, and here's chloride, and it looks like an I. An I stands for insoluble, which means solid. So silver chloride is going to be a solid. Potassium nitrate, let's take a look. There's potassium, here's nitrate. They overlap in an S. Remember, S means soluble, which means aqueous. So now we know that we're going to have an official reaction here. So we can start writing out our balanced equations and all of that because silver chloride will form a solid. Now that we zoomed in, let's get to work. So first off is potassium chloride. Potassium's +1, chloride's -1. Silver nitrate is next. Silver is +1. By the way, you can get all these charges right on that sheet, that solubility curve, chart. After that, we have silver chloride next. Silver is +1. Chloride is -1. And last but not least will be potassium +1 and nitrate, NO3 -1. Now that we have all those charges, we can start putting these together. +1 and -1 for potassium chloride is KCl. Don't forget, it's aqueous, right? Double replacements always start with aqueous. Next is silver nitrate, +1, -1. That's just AgNO3. That's aqueous as well. Next up then is silver chloride. +1, -1 is just AgCl. And remember, that's the solid that's formed. We found that out from the solubility chart. And last but not least is potassium nitrate. +1, -1 just means you need only one of each. And that's going to be aqueous. If you haven't noticed, since everything was +1, -1, this is all going to be balanced out. So you just need ones in there. Nice and straightforward. I like that. All right, if we look at number 20 then, zinc acetate and sodium bromide are going to swap. So now I've got sodium with acetate, and my other product, doesn't have to be in this order, is going to be zinc bromide. Let me scooch up to the top so we can see if sodium acetate and zinc bromide form aqueous or solids. Let's look at sodium acetate. Oh, right there actually, and that is S for soluble, so that's aqueous. And then zinc bromide coming together is right here. Oh, they're both an S. S stands for soluble, which is aqueous, which means both of these products are going to be aqueous. So let's label them both as aqueous. And if they're both aqueous, we wouldn't see any changes really happening when we mix those aqueous solutions together. So we can say that there's no reaction here. Well, that about does it for our quiz review. We went through 3 pages really quick, but don't hesitate to go over things again, look at old notes, and of course, ask questions in class or during intervention time, or get some tutor help during the lunch resource center. But whatever, make sure you're getting your questions answered and you're feeling confident. Great work, Science Fam.